types of titration graphs that can occur. You can have strong acid, strong base, weak acid, strong base, or vice versa, strong acid, weak base.
Yep.
Make sense?
You have weak. You can have weak and strong and strong.
Weak and weak, usually they don't test that.
Actually, that's right. Yeah, they don't graph those because they kind of like, yeah.
It doesn't look like a graph. It looks like God knows what. And plus,
it's hard to tell.
Not only that, it's quite hard for a titration to occur with a weak and a weak because you need something to be able to dissociate. And if you have weak and weak, your equilibrium isn't moving for one of them. The point is no. Usually you focus on these three. So strong acid, strong base. This is the stuff that you need to be, I don't know, looking out for if you ever get a question this in trials or your HSC exam itself. First thing is, to identify that this is a strong acid or strong base, is can you see that it has a very, very long vertical climb?
Yep.
Yep, perfect. So can you see it's like quite long? It's got a nice little thing. And can you see that the middle is around a pH of 7?
Yep.
Perfect. So does that make logical sense? Because strong acid, strong base, you want neutralization, therefore pH is going to be about 7, yeah?
Yeah. They would all sit on 7, shouldn't they? Eventually.
No. Never. Strong acid, strong base, yeah, but the other graphs, no. They're never at 7.
Oh, okay.
Okay. You're going to be writing this down, yeah?
I gotta.
You should.
I gotta see it. Like, it's hard to write this stuff down.
Well, get a piece of paper and a pen. Just write down like bullet points.
So I'm currently doing titration graphs.
Yeah.
Yeah.
So let's just say strong acid, strong base. Your first dot point is going to be long vertical climb.
Yep.
Perfect. Second dot point is going to be the center or the middle is going to be a pH of 7.
Yep.
Perfect. Other thing is your other dot point 3, is going to be that your acid is going to, the pH, the beginning of the acid is going to be 1, and the pH, can you see, of the base is going to be 13. Can you see?
Isn't that depending on which strong acid and which strong base you're using?
They all start at 1. If you're a strong acid, if you're hydrochloric or you're sulfuric, you're going to be at 1.
Okay.
Make sense?
Yep.
All right. Next one. Weak acid, strong base. So can you see, firstly, shorter vertical climb?
Oh, yeah.
Can you see, compare those two?
Yeah, it's longer.
Which one?
The weak acid, strong base.
It's not
It's
longer.
like it's like, oh, but I mean like like it takes longer to reach the straight. Like it's more less steep.
And can you see that the middle equivalence point is a pH, it's always going to be a pH greater than 7.
Okay.
So just write pH greater than 7. That's all you pretty much need to know as a dot point. And that's because this should make sense logically. You're combining a strong base with a weak acid. The pH is always going to be greater than 7, right?
Yeah.
And you can even see this, that at the beginning, can you see that the base has a pH of around 13? And because it's a weak acid, this acid starts at a 3.
Yeah. So, but the equivalence point is longer, isn't it? Like it's got a greater equivalence point. So it's
yeah. So its equivalent point is going to be greater than 7, pH of 7.
Yeah. What about how would you describe the how the steep is shorter, like the
Oh, I would just say the vertical climb is shorter because this has a very long vertical climb, and this one has a much shorter vertical climb.
Yep.
Perfect. Next one. strong acid, weak base. Can you see that it's completely different?
Yeah.
Because
So strong.
just when you had a strong acid, strong base, or a weak acid, strong base, both situations you had volume of base at the bottom. Can you see?
Yeah.
Now we've got volume of acid.
Oh yeah.
And in this situation, can you see that the vertical climb is even more shorter?
Yeah, I can see that.
Perfect. So that's your first dot point. Shorter vertical climb than strong acid, strong base. Yep.
Yep.
Cool. Second point, can you see that the middle of the vertical climb, your equivalence point is going to be a pH less than 7? So in this situation, I think the pH is 5.
2 point less than 5, you say?
Well, in theory, your dot point should be less than 7.
Yeah.
And then can you see that the acid that you begin with has a pH of 1 because it's a strong acid right here. And then the base has a pH of about 11 to 10 because it's a weak base.
Okay.
Can you see that?
So base has pH of 11 to 10. Acid has pH of yeah, pH of what did you say for the acid?
So remember what? Okay, so what is the pH of a strong acid usually?
For a strong one.
Yep.
So they should have like around 13. Oh no, I mean sorry, 1.
Yep. That was like 13. Are you sure?
Yeah.
Yep. Perfect.
Yeah.
That's correct. So the strong acid in this situation will have a pH of 1 at the beginning.
Yep.
And then the base, because it's a weak base, it's going to have a pH around 11, 10, 12, somewhere there. So in this situation, can you see that the base used had a pH of 11?
Yep.
Perfect. Those were your charts. Make sense?
Yep. So you just can look at the equivalence points. Is that what they're used for mainly?
Yeah. So can you see? Here's another one. This is, again, a strong acid. Or actually, where's my favorite one? This one's my favorite. Oh, yep. This is my favorite. Strong acid, strong base. Can you see? So this is the equivalence point right here. Can you see it's a pH of 7?
Yeah.
And that's when you have an equal. Okay, what is an equivalence point used for?
It's to tell when your titration has reached neutralization.
Perfect, correct.
So,
So it's pretty much when you have an equal number of hydrogen ions to the number of hydroxide ions.
Yeah.
Perfect. So you've got your equivalence points. Can you see this beautiful long vertical climb? Can you see that this is a strong acid, strong base one?
Yeah.
Perfect. So equivalent point is really important. And then can you see this kind of like lagging situation right here, which every graph has? That's your buffering region.
So that's where it's what exactly you mean by buffering region?
So that's where you've got the your titration beginning. That's where you're adding your acid or your base from your burette into your conical flask and allowing for the neutralization to begin. Does that make sense?
Oh yeah. Okay.
So that's your buffering region because your goal is to get to here. You want your equivalence point.
Yep.
Cool. Make sense?
Yep.
Perfect.